Hi, everybody. Miss Putman here. Today we are going to continue with NF.4, multiplying fractions with whole numbers. We've been working a lot with unit fractions, 2 times 1/3, 3 times 1/6, and Miss Hall went over more with whole numbers time fractions, not just unit fractions, but 2 times 2/3, 3 times 4/6. Today we're going to work with whole numbers multiplied with improper fractions and how to take that and use it on a number line and then convert it back to a mixed number. So let's go ahead and get this switched for you. As you can see, I went ahead and had this laid out for you so I can explain this for you. So we can look and see that my equation is 2 wholes times 5/3, which is also 5/3. Now we can look at 5/3 and tell it's improper because the numerator is greater than the denominator. So we're going to start on the 0, and you always need to make sure when using a number line, you begin with 0. If you do not start with 0 on the very first tick, you're automatically going to get the question wrong. So always make sure that very first tick is labeled as 0. Now, how can we figure out what to label each tick? We look at our denominator. Our denominator tells us how many pieces are in a whole. And looking at our equation, it says 2 times 5/3. So the thirds tell me that's how many is in one whole. So I would find the fourth tick, should I say, because the very first tick is always 0. But we count from 0 and go 1, 2, 3. So I know that is my one whole, which is also equivalent to 3/3. Now I know that it's going to be greater than one whole already just because my fraction's improper and because I'm multiplying. And when I'm multiplying, I'm making things larger. So I know it's going to be greater than one whole. So I'm going to go ahead and label, like I did, I labeled my ticks all the way to 2. Again, I know it might be bigger than 2 because looking at 2 is only at 6/3, and I'm multiplying 2 wholes by 5/3. So I know it's going to be a pretty big number. So I'm going to keep labeling and keep labeling and keep labeling, and I want to stop at 4. Now, I don't recommend going too high because you might just be labeling ticks and adding whole numbers. It's good practice, but you might be sitting there for a little while. So let's go ahead and work this out, standard algorithm, and then we'll use the number line. If you don't understand standard algorithm, that's okay. The number lines is a tool to help you get there. So when multiplying a whole number with a fraction, you only multiply the whole number with the numerator. Because technically this 2 has a 1 on the bottom. Every whole number has a 1 underneath it because 1 can go into 2 times. If that number was a 10, it would be 10/1. 1 can go into 10 times. So some teachers like to add that invisible denominator of 1, and then they can multiply straight across. 2 times 5 is 10, 1 times 3 is 3. And that is a great trick, but students need to really understand that without the trick, that when you have a whole number, you're only multiplying it with the numerator because the denominator does not change. It stays the same because that tells me how many pieces are in my whole. So we do 2 times 5, which gives me 10. Denominator does not change. So that shows me my answer will be 10/3. Looking at my answer, it is improper. So I can see on my number line, no, exactly right here, it's going to pop right there on 10/3. But how in the world do I get from the 0 to this dot only jumping 2 times? Because this whole number 2 tells me how many times I'm going to jump. So we're going to jump only twice. And this second number, which is my fraction, tells me how many. So we're technically going to say 5, but we know it's 5/3. So pulling out our fraction, our number line bar, we're going to start at 0. Let me get this to the end. And we're going to count 5 ticks because we're counting 5/3. So 1, 2, 3. I just hit a hole. 4, 5. That's one long jump. And that's why it's very crucial that you always label your ticks. It's very important that you label those so you don't get them mixed up. And so you always remember that 0 is where you start. So I did jump 5/3 once already. However, I need to jump 5/3 twice. So I'm going to do the exact same thing. I'm just going to grab another number line bar and count 1, 2, 3, 4, 5. And it does end up at 10/3. Now you can look at the number line and see where your mixed number lies. So we can see that 10/3 does lie between the two whole numbers 3 and 4. And it's right past the 3. So we can see it's really close. Excuse me. So we're going to take that 10/3. There we go. And we're going to put equals to 3 wholes at least. Now we got to figure out what the fraction is behind it. Right here is my 3 wholes. I'm going to put a line right there for you so we don't lose it. 3 wholes is right here. And regardless of how many ticks are from 3 to 4 or how many ticks are behind, you're just counting looking at your denominator. So I am going by thirds. So how many ticks am I moving from 3 wholes to my dot on the number line? And you can see is only one jump. So my mixed number is 3 and 1/3. It is not 3 and 10/3. It is 3 and 1/3 because right here is your 3 wholes. And you're only jumping over one tick. Denominator doesn't change, and you're just jumping one because everything 9 and behind on the improper part is basically gone. It's been converted into 3 wholes. So you just have 1/3 left over. So let's move on to our second one, which is 3 times 6/5. Now, I went ahead and added the 0, but I want to show you if you do not understand when to add your wholes, how many labels. We're going to work on this one just using the numbers that are given and understanding what each number means. So looking at this, 3 times 6/5, I know 3 is a whole number. And I know 6/5 is not just a fraction, but an improper fraction. And because it's an improper fraction, it's going to be greater than 1. But even if I didn't understand that, we're still going to just work with the two numbers and my knowledge of what they mean. So I'm going to jump 3 times because that is what my whole number tells me. I'm jumping 3 times. Referring back to our first question, you can see here I only jumped twice. 1, 2. So on this number line, I'm going to be jumping 3 times. And how many times? 3. I will be jumping 6/5 3 times. So looking at my denominator, that tells me that each tick is worth 1/5. So I would label each fifth and I would go all the way until at least, let me get this pulled up right there, at least to 6/5. But let's say again, you're still confused. You don't know why I put 1/5 or 2/5 down there. Just watch this. Let's go ahead and delete this. Let's just pretend you have no clue how to label them. And that's okay. It's a new skill you're still learning. So we know we're going to jump 3 times and we're going to jump 6/5. One thing I do ask is you remember that first tick is always 0. If you mess up on that, you will get your answer wrong by one off, one greater or one less. So we're just going to start right here on this very first tick and we're going to count 6, just 6 of them. So 1, 2, 3, 4, 5, 6. I'm going to put a dot on that 6th one. Let's do it one more time. Get that squiggle up for you. 1, there we go. 1, 2, 3, 4, 5, 6. All right. There's my first jump of 6 because it says to jump 6/5, so I just jumped 6. Now let's do it again. 1, 2, 3, 4, 5, 6. And then let's do it one more time because I know I have to do it 3 times. 1, 2, 3, 4, 5, 6. You're probably wondering why I'm going by ones. I am going by ones because I don't have my ticks labeled. And that's okay. That's okay. But in reality, what we're doing is 1, 2, 3. And when your ticks are labeled, it's easier for you to see that. Now I can see that my number line is the ticks and the dots and the carryover is correct. But now let's label because I still don't know what my answer is. So let's go ahead. I'm not going to label all of them because that's a lot. Normally I wouldn't care, but I have to type all of these in. But I do know 6 times 3 is equal to 18. My denominator does not change, so my dot will land on 18 over 5. And if you did not remember that 3 times 6 is 18, then just count your dots. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So right there, 18, denominator does not change. So if I didn't know 3 times 6, or I forgot that I needed to multiply my whole number with my numerator, all I needed to do was just count the number of ticks all the way to my last dot. So I jumped 3 whole times, and then I jumped 6/5, 6/5, 3 whole times, which ended up at 18 over 5. 18 over 5. Let's add that down here. So if I was to go back and add these ticks, 17/5, 16/5, 15/5, so and so and so and so, you would see that it does come up to be 18/5. Now, let's go ahead and turn this into a mixed number. This is where it gets a little tricky because 18 over 5 does not go into 18 evenly. So let's see what happens. Let's see, let's go ahead and let's find my first whole, which this is where it is important that we understand the denominator, because if I don't understand my denominator is the number of pieces in the whole, then I'm really going to mess myself up. So my denominator is 5, so I start at the 0 and I count to 5. 1, 2, 3, 4, 5. It's in a different spot than your first dot because you went to 6/5. You're just basically going back 1 tick to 5/5, which a number over itself is equal to 1 whole. So starting at that 1, count 5 more. 1, 2, 3, 4, 5. So we're going to put a 2 there. So 1, 2, 3, 4, 5. 1, 2, 3, 4. There we go. And if I was to label, this would be 5/5, 6/5, 7/5, 8/5, 9/5, 10/5. 10/5 right here. All right, let's go ahead and count 5 more because I'm not yet at the end of my dot. 1, 2, 3, 4, 5, which will give me 3 wholes, which is basically 15 over 5. Let me count that, make sure. 1, 2, 3, 4, 5. Yep. So that's 15 over 5. And you can see I'm almost to that dot, but I don't go 5 over. I only go 1, 2, 3. And I can go ahead and add my 4 if I'd like. So let's go ahead and do that just so you can see it. 1, 2, 3, 4, 5. So this tick is where the number 4 goes. And these are whole numbers. These are not fractions. 1, 2, 3, 4, 5, which would give me 20 over 4. Fractions are basically just division. So 5 right there. Okay, so I can see my mixed number is going to lie between the whole numbers of 3 and 4. It is not yet to the 4, so I know it's going to be equal to 3. So 18 over 5 is equal to 3 something. We got to figure that out. That's where we got to dig down. So we can find here's where my 3 is. And starting at that 3, I'm going to draw a straight line for you. We need to count how many ticks over our dot is from the 3 holes. Because remember, everything behind the 3 no longer exists because it's been turned into whole numbers. It's kind of like taking 100 pennies and turning it into $1. It's still equal to 100 pennies. They've just condensed it into $1 bill. Same with this. We've taken those ticks and combined them all the way, those 15 ticks, and just put them into 3 holes. Now, the last few ticks I can't put into a group. I have to only put them in groups of 5, and I don't have enough. So what's my leftover? Starting with the 3, we can count 1, 2, 3, which is where that dot is. So my answer is 3 holes with 3/5. Now, if you get done and you notice your answer still is improper, like let's say this was 3 5/3, then you messed up somewhere. So you might need to go back and check your dots to make sure you put them in the right spot, make sure you labeled correctly, make sure you didn't skip a whole number by mistake. There's a lot of careless things you can do on a number line, so make sure you really look at each component and it is labeled correctly. Let's do one more. And for this one, I had not labeled anything. So at this point of the video, I would like for you to push pause. And I'm going to have you label the number line if you can. Work out the equation with standard algorithm if you can. If you need to draw models, please do. This is completely um, whatever strategy works for you. But I am going to only be focusing on using the number line to solve this problem. And I'm going to try to combine the strategy from the first equation I did with the second equation so you can see how they mesh together. So if you would, go ahead and push pause and attempt this problem for me. All right, I'm sure you did great. Let's go ahead and label these. So the very first thing I know that it's on your number line that will match my number line is that we both start at 0. If you start at 0, give yourself a high five. And let's see, can anybody tell me where my 1's going to be? I heard it. I heard it over there on the west side. Someone said the 1 whole is going to be on the first tick. Is that right? No? That's not right, is it? Where does it go? The second tick. Why? Because my denominator is 2. So my 1 whole is actually equal to 2 over 2. I'm going to put that right up there so you can see it and we don't lose that. Now, again, we are working with improper fractions, so I know it's going to be greater than 1 whole. So I'm going to keep going. I'm going to go at least 3 times because I know I have to jump at least 3 times. So I'm going to go ahead and go to the whole number of 3 and see what happens. So 1, and then we would continue. I'm going to put a 2 right here. I just go 1, 2, because 1 whole is 2 over 2. So 2 wholes would be 4 over 2, because 2 can go into 4 2 equal times. There we go, 2 over 2, 2 over 4. And now we need to go ahead and label the 3. Bring down the 3. And this is what's nice about halves. You only have to do 1 tick because there's only 2 parts of the whole on this one, which is nice for labeling. You don't have to label forever, but it's very helpful. So always do it. 6 over 2, because 2 goes into 6 3 times. Now, let's see. I need to jump. Let's stop there because I can see if my whole number is 3. I'm jumping 3 times. Let's see what happens. So I need to jump 4 halves 3 times. So I'm going to grab my first box, start at 0, and I'm jumping from 0 to 4 halves. And right there it is. I jumped 1 time. Now I need to do that 2 more times, 2 exact times. So jump. Uh-oh, what happened? I went past my label. So at this point, you have an option. You can go ahead and do the exact same thing and jump again and then go back and label, or you can stop and go back and label what you have and then continue from there. So for this purpose, I'm just going to go ahead and continue jumping like I did because I can see my 3. I jumped 3 times and I jumped 4 halves because I jumped 2 wholes, because what's 2 over 2 equal? 2. So let's go ahead and label these. Let's see. 6 halves, 7 halves, and then 8 over 2 is equal to 4. And if you look right there, that's where my last jump was. That's where it landed, which was 4 holes. So I'm going to put a 4 hole right there. And let's go ahead and put a 5, which is going to land right here. And that as a fraction is going to be 10 over 2 because 2 can go into 10 5 equal times. And now if you can see, I'm not at my dot. You can put a little dot there if that makes it easier for you. But you can see I'm still not there. So this is greater than 5. And I bet that's higher than some of you are used to. But that's okay. You're going to get a lot higher when you get older with the fraction numbers. So this is a good starting point working with halves, having to have your answer greater than 1, 2, or 3. Higher than 5 is pretty, it can get pretty tricky. So I'm not yet to my dot. So I'm going to continue with my labeling. This would be 10 halves, 11 halves, and then where the dot is equal to 12 halves. So my answer is equal to 12 halves, but there's something about 12 halves, which is that it is improper, and it can convert to either a whole number or a mixed number. Now, if we know our multiplication tables, we know that 2 goes into 12 an even number of times. And also looking at my number line, I can see that that even number is going to be 6 because I'm going up by 2's all the way starting from 0, 1 half, 2 halves, 3 halves, 4 halves, 5 halves, 6 halves, and so forth, all the way to 12 halves. And if I was to have 12 dots and put them in groups of 2, I would end up with 6 equal groups of 2. So when you're multiplying a whole number with an improper fraction, the same rules apply as if you're multiplying a whole number with a proper fraction. Don't let it confuse you. If you don't understand still about the labeling, go back and watch what I did on the second problem. I didn't label anything. I just looked at how many times I was going to jump, which was 3, and I knew I was jumping by 6/5, so I started at the 0 and I counted 6. 1, 2, 3, 4, 5, 6, and I circled my first dot. Then I did it again because I knew I had to jump twice more, and there I landed on this tick. And all I had to do was count 1, 2, 3, 4, 5, 6, all the way. Now I saw that I was 18/5. So if your answer is improper form, you're in good shape. However, if it's in mixed form, that's where it gets a little hazy sometimes, and we have to make sure we understand how to convert that into a mixed number. You can draw it out using models. I love to do the models. I feel like that's a lot easier. Some like that visual, and some like to use their number sense and mental math, and that is perfectly fine too. All of us are different. We all learn different ways. So I hope this video has been helpful. I'm going to turn myself around real quick, and I hope you will let me know if you have any questions, and I will talk to you soon.